Hi, students. My name is Nicholas Shumaker. As you probably already know, I'm your professor. And here we're going to be starting on our textbook, which is Elementary Statistics, 14th edition, by Mario Triola for my Math 10 online course. So this is my first time teaching Math 10 online, so I will be getting used to this new recording setup that I have here. Hopefully it works well. Okay, so today in this video we're going to be doing 1.1, which is statistical and critical thinking. Now keep in mind that the entire first chapter of our book doesn't really involve any math. It actually just involves sort of the vocabulary words and the science behind the math that we're going to be doing later in the course. So I'll primarily just be going through the slides for this week. And then when we move on to chapter 2, then I'll start writing math on this whiteboard as we need it. Okay? All right. So what we're going to be doing first is talking about a statistical study. Statistical thinking involves critical thinking and the ability to make sense of results. Statistical thinking demands so much more than the ability to execute complicated calculations. So this is why I like to say that statistics is really both a science class and a math class. People think of it as a math class, but there's a lot of science behind it. And most of the problems we'll be doing later in the course will be word problems, but they're not just word problems, they're word problems taken from the real world. Okay? All right, so let's start with our first vocabulary word. This should be pretty familiar for most of you. Data is a collection of observations such as measurements, genders, or survey responses. Okay? Data is what we gather when we're making a statistical study. Okay, so for example, we could be gathering data for if medical researchers are doing a study to make sure that a drug that treats anxiety is safe. They would be gathering data by giving a bunch of people both the drug and then also the placebo, which we'll talk about more in the next section. But data is just the information that we're gathering for our study. Okay, next word, statistics. So this is the name of our course. So in statistics, it's the science of planning studies and experiments, obtaining data, and organizing, summarizing, presenting, analyzing, and interpreting those data, and then drawing conclusions based on them. So for example, if we have a study with 200 people and we're testing an anxiety drug on them, we might have a group of 100 people who take the actual anxiety drug, and then we have 100 other people who take the placebo, which would be a sugar pill that doesn't have the drug in it. And statistics would be the process of gathering the data to see if these two groups have an improvement in their anxiety. And then after we gather the data, then we have to organize the data, summarize the data into tables and graphs. We need to present the data, analyze the data, and that's where the math comes in, because obviously we're going to have a bunch of numbers, and then we're going to have to do math to try to make interpretations of that data and then also draw conclusions based on the data. Okay, so that's the science of statistics. Yes, it involves math, but it's also a lot of science behind it. And really, this first chapter is all about the science behind it. Okay, so next thing that we're going to talk about is a population. So a population in statistics refers to the complete collection of all measurements or data that are being considered. Typically, a population is the complete collection of data that we would like to make inferences about. Now, inferences mean where we try to figure something out about the real world based on this collection of data that we have. But an inference is sort of like a guess, okay? Because realistically, you're probably, if you want to do a study on everyone living in the United States, you're not going to be able to include everyone in your study. Okay, but the population would be everyone in the United States. Okay? And like I said, we probably wouldn't be able to afford or even get everyone to be in our study if we wanted to do a study of all people living in the United States. But if we were somehow able to do that, that would be called a census. So the thing about censuses is these are usually problematic because if your population is pretty large, you're not going to be able to collect data from every member of the population. Like, just imagine the amount of money you would have to in order to get everyone in the United States to be in your study. It's just not going to be doable in most situations. So what's going on here is we actually have a population, like I said on the previous slide. The population is going to be all individuals of interest. So that's going to be the large group from which our data is drawn. But realistically, because we can't do a census for this entire population, instead what we can do is maybe gather, a few hundred people to be in our actual study. That's all we could really afford. So then those people that we gather to be in our study, our statistical study, is called the sample. Okay? So for example, our sample here might only have, like I said, a few hundred people, but the population could, for example, be, more than 1 billion people who are in the United States, or our population could even be all humans living on Earth, which would be huge, right? Billions and billions of people. So realistically, we can't do a study on the whole population, but we can gather this little sample, and statistics is the science and math where we take our little sample and we try to make inferences or guesses about the whole population. And because of the way math works, we're actually able to do this, which is pretty insane that we can actually do that. But that's the magic of statistics, is that we're able to have a little sample, but we're actually able to do science that is meaningful for a larger population. Okay, so just remember, sample is the little part, and then population is everybody of interest. And realistically, can we do a census? Not in most cases. Now, there are situations where you could do a census. For example, if our population were just everyone, all the students at a particular school, then our population might be small enough that we could do a census. But realistically, in most cases, we can't do a census, so we can't collect data from the whole population, so we're stuck with our sample. Okay? All right. And then let me go to the next slide. Okay, so let me go ahead and erase this while you're looking at that. So on this next slide, it says, this is our first example, but it's not really math. Again, it is more like a science course for this first chapter. In a survey of 410 human resource professionals, 148 of them said that job candidates were disqualified because of information found on social media postings. Okay, so my question for you, before I go to the next slide, would be, what do you think the population is here, the larger population? And then what do you think the sample is? So think about that for a second. You can always pause the video if you want to think about it on your own. But remember, the population is the large group of which everything that we're interested in. And then the sample is just the people in our actual study. So the actual people in our survey would be the sample. Okay, so in this case, the population and sample are as follows. The population would be all human resource professionals. Okay? So I don't really have room to write that here, but this population here in this particular example would be all human resource professionals. And because they weren't more specific, I believe that would mean all human resource professionals either in the United States or in the world, which would be a very large population. Okay? But then in our sample, those would be the 410 human resource professionals who were surveyed. So remember, in this problem, they gathered 410 human resource professionals. That's called the sample. And then the way they figured out the population is the population. I don't know why I circled population. That was kind of silly. That's not very enlightening. I guess it's because I was talking about it. Sometimes I like to circle things that I'm talking about, but that could be a little misleading here. So anyway, the population would be all human resource professionals in the world or in our country, which is, millions or maybe more of human resource professionals in the population, but only the 410 human resource professionals in our study are in the sample. Okay, and then the 148 of them said that job candidates were disqualified because of information found on social media postings. We don't need the 148 yet. Like I said, we're not really doing math yet. We're just trying to identify vocabulary words and identify the different scientific structures that are behind all this stuff. Okay? All right. So pretty straightforward. Population is the large entire population from which we're drawing individuals, and then the sample are the individual people in our study. Okay, now let me erase this. All right, so on this next slide, these are actually the slides that come with our textbook. And they have a long list of steps that are involved. If you are actually doing the science of making your own study, then that would be, you would use this flowchart. But fortunately in my course, we're not going to be doing a project, at least not for this course. So you won't really need to use this whole flowchart, but I left it in here in case you're interested. It shows you all the steps that are involved in running your own statistical study. So this is what you would do. You would follow this flowchart if you were trying to do statistics and do like a project or something in the real world, like when we're talking about the anxiety drugs. If you had to do a study, you would have to do all of these steps. But just real quickly, we've got prepare. So your first step is to prepare all the data. So you'll be talking about the source of the data, the sampling method, which we will learn about very soon. So how do you gather your sample? So the sample, remember, is the little part of the whole population that's actually in our study. And then the sampling method is going to be how we gather those people for our sample. Okay, and I keep saying people, but keep in mind that statistics doesn't have to just be done on people. It could also be done on animals. It could be done even on molecules. It's done in physics. It's done in all sorts of applications. But I like to always just go back to my favorite example to come back to, because it's very real world, is studies involving pharmaceutical medications, drugs, because there are, thousands or hundreds of thousands of drugs that are available. And all of those drugs, the prescription drugs and the non-prescription drugs that you get at the pharmacy, all had to go through rigorous statistical studies that followed all these steps. Okay, so anyway, sampling method we'll be talking about soon. Now, the rest of this flowchart, analyze, where you graph the data, explore the data, do math, this will be later in the course. This first chapter, we're just going to be focusing on the prepare part, which is this first part. Okay, and then also if you're doing a full study, after you've done all the math, then you have to draw conclusions. For example, going back to the anxiety drug, the scientists need to come to a conclusion. First of all, does this anxiety drug actually appear to improve people's symptoms? Or does it appear that it doesn't really work that well, in which case they would never put the drug on the market for people to buy. And then, of course, there are other things that scientists have to do, like make sure that the drugs are safe. But all that stuff is statistics. But after you do all the math, which is analyze, then you conclude and decide what all this math means in the real world. Okay, cool. So it's good to talk about that. So when you're preparing data, here's an example of a table, which is something that we're going to be doing later in the course, actually as soon as Chapter 2. This is a table where shoe print lengths is the first row of the table, and then heights of 8 human males would be the second row. So I know we're used to thinking of heights as being, for example, 5'11" inches, but this is in centimeters. But it still represents the height of the men that were in the study. So what this table is indicating is there would be a total of 1, 2, 3, 4, 5, 6, 7, 8 people in the study. They were all male, it says, 8 males. And then the first row represents the size of their shoe print and their shoe, and the second row represents how tall they are. Okay. But we're not going to be doing math yet. I just wanted to show you an example of a table. And a table is a nice way of organizing data, and that's part of the prepare step, which again, going back to this slide, we're just going to be focusing on the prepare step for Chapter 1, which is really, can we trust the source of the data? That's something we'll be talking about. Or is the data biased? And then also, sampling method. How do we collect our sample? And then also there are things like this over here. So context, what do the data represent? And what is the goal of the study? Okay. So this is some information down here that they include from the book. It says the table includes shoe print lengths and heights of 8 males. Forensic scientists measure shoe print lengths at burglary scenes and other crime scenes in order to estimate the height of the criminal. So apparently these are actually not just adult males, but they're criminals. Okay, and then the format of the table suggests the following goal. Determine whether there is a relationship between shoe print lengths, so how big their shoes are, and their heights. This goal suggests a reasonable hypothesis. Now, a hypothesis is a guess. So remember, in statistics, what we're trying to do is we're trying to make educated guesses about the whole population when we just have a little sample. Okay, so here they're saying males with larger shoe print lengths tend to be taller. So that seems pretty obvious from the real world. But this is an example of preparing your data for statistics, and this is context. This is stuff that you would use if you were actually doing an entire statistical study. Okay, and then here they're saying we're using data for males only because 84% of burglaries are committed by males. This is just an example out of the book. But I wanted to show you the kind of background behind everything. So when you're preparing, on the next slide, you need to worry primarily about a couple of things. The first thing is the source of the data. Okay, so the source of the data is very important. So you need to think about whether your data comes from a reputable or reliable source. And we'll be talking about that all through this first chapter. So it says the data in the table are from data set 9, foot and height in Appendix B. This is actually out of our book. It's an example out of our textbook, the Triola book. Where the source is identified, the source certainly appears to be reputable. So reputable just means that you can trust the source. And later on, we'll talk about sources that are not reputable, things that you can't trust. But just a real quick example of something that wouldn't be a good source would be something that's biased. So we'll talk about this more later. Oops, I wrote that too high on this little board. Okay, so we'll talk about it more, but bias would be, is basically, it's bad. Okay, it's bad because it means you can't trust the source. So, for example, so an example of bias would be probably the easiest one for me to think of just off the top of my head would be, let's say you're trying to do a scientific study, a statistical study on the effects of cigarettes on people's health. So an example of bias would be if you had cigarette companies running the study. Okay, so here my quick example would be, example of bias would be cigarette companies. I didn't spell cigarette right. I think it only has one R. Yeah, that looks right. Okay. I'm not an English major, so I apologize if I didn't spell right. But cigarette companies or a cigarette company runs a study, so a statistical study, and gathers data, prepares the data, analyzes the data, concludes and tells us conclusions. And if they're running their study on cigarettes and health effects, so the effects on their health of people, obviously anyone just from the real world should be able to see why this is problematic, because, oh, that's kind of cut off. Sorry, I'm getting used to this board, so bear with me. Okay, that helps. So let me just switch to this board. So an example of bias would be a cigarette company runs a study on cigarettes and health effects. The issue there is a cigarette company would have a special interest in changing the way the statistics were done. So you can't really trust the data that they present to you, because you would expect them to want to change it to make it seem like cigarettes aren't as harmful as they might really be. Okay, in other words, you can't trust the data. So bias really just means data is not trustworthy. It's not from a trustworthy source. Okay, so essentially that's all it means. So bias just means data are not from a trustworthy source. data are not from a trustworthy source. Okay, and the only reason I'm writing this up here is on our slides, it doesn't really go into detail about bias. These are the slides that come with the book. But it's a very important thing to understand. So if you can't trust the source of the data, then you can't trust any statistics that are done. So you can't trust a cigarette company to do a study on cigarettes and health effects because they have a special interest in changing the data. Okay? All right. So I need to erase this. All right, but while I do that, I'm going to go ahead and bring back up the slides. Okay, and then I'll talk about this slide as I erase this. So, but the example here on shoe print lengths and heights of males, this example from the book does appear to come from a reputable or trustworthy source. So as far as we know, that one is not biased. So when you're doing your homework and your quizzes, and also the exams, they're going to be based on these slides. So you'll have a variety of questions, but if you ever see a problem where they're asking you, does this data appear to be biased, or does this source of data appear to be biased? Just think about it. Is it something that you can trust, or is there a reason to not trust it? And in most cases, if you can't trust it, it's because someone is being paid money to try to change the results. For example, a company trying to sell a product, that kind of thing. But something that would be trustworthy would be data that was gathered by nonprofit scientific researchers, that kind of stuff. So that would be not biased. Okay, and then another form of bias comes in based on the sampling method. Okay, so remember the sample is our little part of the whole population, just in our little sample. And the way that we gather the data and the way we sample or choose the people or animals that are going to be in our sample is called the sampling method. And we'll talk about sampling methods that are, here they're saying it appears to be sound. When they say it appears to be sound, that means it's not flawed and it's not biased. Okay, so that's just kind of like an introduction to all that. So let's go on to what else is on there. Okay, so we just talked quite a bit about bias. Now I wanted to talk about one of the most common forms of bias from the real world, which is shows up all the time in a lot of statistics that people do, and it's called a voluntary response sample. Okay, so a voluntary response sample or self-selected sample is one in which the respondents are the people who are responding to a survey. Okay, the respondents themselves decide whether to be included. Okay, so the respondents themselves decide whether to be included. And again, respondents just means the people who are responding. So a lot of studies that are done these days that aren't actual scientific studies are voluntary response samples. And these are considered biased. Okay, so voluntary response sample is biased because people have the choice as to whether they want to be in the study or not. That's what makes it biased. And remember, bias is bad. It means you can't trust the data and you can't trust any statistics that are done with the data. It doesn't mean anything. So voluntary response sample is biased, which is bad. That means you can't trust, it's not trustworthy, so you can't really do good statistics on it. So what would be an example of a voluntary response sample from the real world that people use all the time? Well, there are actually a lot of examples. So to be a voluntary response sample, that just means that people have the right to either choose to be in the sample or not be in the sample. So for example, Yelp reviews. A lot of people use Yelp when they're trying to look at restaurants. The thing is, all of those Yelp reviews were written by people who wanted to write a review for one reason or another. So the reason it's biased and it's bad is because those people who choose to be in the study very often have strong feelings about a restaurant. So for example, they might want to write a 4 or 5 star review because they love the restaurant, or they might want to write a 1 or 2 star review because they hate the restaurant. So it's very polarized. You have all the people who hate the restaurant and all the people who love the restaurant. Those are most of the people who write the reviews. But then people who just have like an average time at the restaurant would be less likely to want to write a review because they might be kind of like, oh, well, this restaurant was okay. It wasn't terrible. Wasn't great. I don't feel like writing a review. So then you have a bunch of data that is just written by people who want to write a review. So that's flawed, and flawed is bad. It's biased. Okay, you can't trust it. Another example of voluntary response samples is any other kind of thing, like with video games on Metacritic or on Steam, where people choose whether they can write a review or not. That's another example of a voluntary response sample. A lot of people are just going to write a review if they feel like writing a review. But you're not going to hear from all the people who just didn't feel like writing a review, which makes it biased, which means you can't trust it. Okay? All right. So, unfortunately, a lot of things in the real world that we base our modern society on are voluntary response samples. So the reason we're learning about them is just so that we can realize that they aren't that valid. The statistics that you do with a voluntary response sample is a lot less meaningful. Okay, so let's see some more examples of voluntary response samples. Okay, so here it says, by their very nature, all are seriously flawed because we should not make conclusions about a population on the basis of samples with a strong possibility of bias. And again, as we talked about, they are biased because everyone who's writing a review on Yelp is someone who wanted to write a review, but we don't have reviews from all the people who went to the restaurant and just decided they didn't want to write a review. So it skews the data. It's not going to be something that we can trust. It's biased. Okay, so some other examples would be internet polls in which people online can decide whether to respond. Okay, so can't trust those. Mail-in polls, same idea, just polls through the mail in which people can decide whether to reply. Telephone call-in polls in which newspaper, radio, or television announcements ask that you voluntarily call a special number to register your opinion. Okay, but then we also have like movie reviews. That's not on here. They didn't say that in our book, but if you have movie critics who write reviews just because they want to, but then they don't write reviews if they don't want to, then that's another example of a voluntary response. So like on Rotten Tomatoes, that kind of stuff, those are all voluntary response samples because people can choose whether they want to rate the movie or not. Okay, example, voluntary response sample. The ABC television show Nightline asked viewers to call with their opinion about whether the United Nations headquarters should remain in the United States. Viewers then decided themselves whether to call with their opinions, and 67% of 186,000 respondents said that the United Nations should be moved out of the United States. In a separate and independent survey, 500 respondents were randomly selected and surveyed, and 38% of this group wanted the United Nations to move out of the United States. So, before I go to the next slide, I want you to think about this. Think about this one up here and then this one down here, and see if you can decide which of these is a voluntary response sample and which one isn't. And you can always pause the video if you want to. Think about it and then come up with your solutions, and then you can unpause the video. Okay? So let's go to the next slide. Let's see which of these is a voluntary response sample. Okay, so the two polls produced dramatically different results. Even though the Nightline poll involved 186,000 volunteer respondents, the thing about this larger study, this one up here, the Nightline poll, is even though there are 186,000 people in it, we can't trust it. This is biased. And the reason this one is biased is because it's a voluntary response sample. All those people decided themselves whether they could call in with their opinions, or if they just didn't want to call in, then those people, we didn't hear from them. So it's biased, it's flawed. However, this one down here, even though it only had 500 people in this study, they were randomly selected and surveyed, but it doesn't say anything about those people having a choice about whether they wanted to be in the study or not. So this one up here, even though it has 186,000 people, we can't trust it. This one is biased. But this one down here, even though it only has 500 people, we can trust it because the people were randomly selected and surveyed, and they didn't have a choice whether they wanted to be included or not. And a voluntary response is also called a self-selected sample. So that's where people can select themselves to be in the study or say, no, I don't want to be in the study. But that's not good. You can't trust statistics that way. So what they say in the book is the much smaller poll of 500 randomly selected respondents is more likely to provide better results because of the far superior sampling method. Okay. And that far superior sampling method was people were just randomly selected and then they were surveyed. And those people who were randomly selected, we didn't ask them whether they wanted to be in the study or not. They were just randomly selected, and we surveyed all those people. So that is not biased. Okay, so like I said, later in the course, we're going to be focusing more on analyzing the data, which has to do mostly with math, but it also has to do with graphs and applying statistical methods. So analyzing, after completing our preparation by considering the context, source, and sampling method, we begin to analyze the data. And in Chapter 2 and Chapter 3, and throughout the rest of the course, we'll be learning how to make graphs, and we'll be learning how to explore our data. So an analysis should begin with appropriate graphs and explorations. And then, like I said, we'll be doing math. So we'll be applying statistical methods. A good statistical analysis doesn't always require strong computational skills. I kind of disagree with that. I think it's important to be good at the math. But these days, you can use calculators to do a lot of the work for you, and computer programs. However, a good statistical analysis does require using common sense and paying careful attention to sound statistical methods. Now, the word sound means it's not biased, so it's good. Remember, bias is bad, not biased is good. Okay, so then, like I said, later in the course, after we've analyzed the data, we've made graphs, we've done the math, the final step will be to conclude our statistical process. Conclusion means you finish it and you have to make a decision. You need to say either the data supports that our anxiety drug helps reduce anxiety, or our anxiety drug does not appear to have any effect. So that'll be hypothesis testing, which is maybe chapter 8 in our book. Okay, and then the important thing here that we need to learn about, though, is statistical significance. Statistical significance is achieved in a study if the likelihood of an event occurring by chance is 5% or less. So basically, it's just saying that something has statistical significance, which is like statistical meaning, if the chance of that event occurring is very small. Okay? That's another way of saying what they just said. So if the chance is 5% or less, which is a very small chance, then it has statistical significance, which is really like mathematical meaning. Okay? It has meaning in math. So here they say, getting 98 girls in 100 random births is statistically significant because such an extreme outcome is not likely to result from random chance. But down here they say getting 52 girls in 100 births is not statistically significant because that event could easily occur with random chance. If you think about it, in some couples, in a lot of couples, the chance of having a boy versus a girl might be around 50-50. Some couples would be different. But on a lot of couples, it might be somewhere around 50% chance of a boy, 50% chance of a girl. So if you had about half of the babies are girls and then about the other half are boys, that's very common. So that's not statistically significant. That's what they're talking about here. Whereas having 100 babies, but 98 of them have a biological gender of female, and only 2 of them have a biological gender of male, that's statistically significant because it's an event that is unlikely to occur by chance, right? You're very unlikely to have 98 girls in 100 births just by chance. There must be something going on. Okay, so when you're doing your homework, I know we haven't gotten to do any math, so this first chapter can sometimes be a drag for some people. Some people who hate math actually like the first chapter of the book. But I wanted to point out that when you're doing your homework on my math lab, we're going to be going through all this stuff on the slides, but you'll have problems that are primarily multiple choice, and they will ask you mostly questions about, they'll write out a sentence and you'll just have to answer. There's sort of like vocabulary and science questions about all the stuff that we're covering on these slides. Okay, and then, so what we just went through here was statistical significance. That's something that has mathematical meaning. Now on the next slide, we have practical significance. Now practical significance would be something that has meaning in the real world. Okay? So let me go to here. Just to summarize, because this is important, it shows up quite a bit in your homework from 1.1. Statistical significance unlikely to occur by chance. That's my best way of summarizing that. Unlikely to occur by chance. So really that has mathematical meaning. Because remember, statistics is math. It's really math and science. But if it has statistical significance, it's unlikely to occur by chance, which is meaningful mathematically. But then what do we say if something is meaningful in the real world? Well, that's what we call practical significance. And that shows up quite a bit in your homework, so let me write this down. So practical significance is essentially just something that is useful in the real world. And as we all know, math is a tool And just like any other tool, it's only as useful as the people using it. So if you do the math correctly, that's great. You might have something that's statistically significant, unlikely to occur by chance. But then the practical significance would be, well, does this thing that we're studying actually have any use in the real world? So usefulness in the real world is the same as practical significance. Okay? So the reason we're learning about this is in some cases we can do math on something, we can do a study, and we'll encounter something that's unlikely to happen by chance. So we can say it has mathematical meaning, but just because something means something in math doesn't mean it's going to be useful in the real world. Sometimes it is, but what's important here is sometimes things can have statistical significance, so they can have mathematical meaning, but it turns out that they don't have practical significance, so they're not useful in the real world. Okay, so that can be an issue. So let's go back to the slides, since we got through that. Okay. So practical significance says, on this slide, it is possible that some treatment or finding is effective, but common sense might suggest that the treatment or finding does not make enough of a difference to justify its use or to be practical. Okay, so that's basically just saying it's not useful in the real world sometimes, even when it seems like the math is telling us that it's useful. Okay? You might have something that's unlikely to occur by chance, but then when you actually try to apply it to the real world, it's pretty much useless. Okay, so let's see a quick example of that. Okay, so, well, maybe not so quick, but I apologize if my videos are long, but I like to talk in detail about stuff. Remember that these lecture slides are also just available for you on Canvas if you're in my course, and then you'll be able to just go through them on your own. But these videos, I try to lecture just as if we were in person, so I talk about all the details. It can be, so that's why the videos can be long, but I feel like it's good for some people who need all that information. So that's why I'm spending lots of time. All right, so in this example, in a trial of weight loss programs, 21 subjects on the Atkins program lost an average of 2.1 kilograms, which is 4.6 pounds, after 1 year. Okay. And this is based on data from the Journal of the American Medical Association, which is, the American Medical Association is a reputable source. So it's not biased because it's scientists who are not, very likely not being paid to change the data or to change the conclusions about the data. So this is not biased, so we can trust it. It's a trustworthy source. Anyway, the results show that this loss is statistically significant and is not likely to occur by chance. Okay, so in this particular study that was done on the Atkins program, they found that this has mathematical meaning because it's unlikely to occur by chance. Statistical significance, however, just think about this. After an entire year of dieting, these people have only lost 4.6 pounds on average. Does that sound like it's useful in the real world? You spend an entire year and you lose less than 5 pounds on average? No, that does not sound useful in the real world. Most people want to at least lose 20 pounds or 30 pounds for it to be worth it. But anyway, I just had to pause the camera, but what I was trying to say is this is an example of something that has statistical significance because it's unlikely to occur by chance, but it does not have practical significance. So it does not really have meaning for the real world. And when you're doing your homework and your quizzes and your exams, just look to really your vocabulary definitions that I've gone over here in the slides. So statistical significance means it's unlikely to occur by chance, but this practical significance is not there because it's something that is not useful in the real world. Okay, thank you for watching. That was my video for 1.1, which looks like it's almost an hour long. I will try to maybe shorten these videos a little bit, but I like to just talk for a while, just like I do in the real world. And you're obviously welcome to skip around in the video, or if you find a lot of this stuff to be easy, you don't even have to watch a particular video if you don't want to. But a nice thing about videos is you can re-watch different parts of them, that kind of stuff. So that's really useful. Okay, thank you for watching.